All right, you guys. So today, let's see if I can get this angled right. So today we're going to be talking about direction angles. A vector. So if u is a unit vector, then u equals the unit vector xy. So I'm going to draw this xy. Okay. So remember, a unit vector starts at 0, 0, and it goes the length of the vector. Okay, and so that's actually going to be the same thing as the vector cosine theta sine theta. So here's our cosine theta, which is our x, and our sine theta, which is y. Okay, so we're going to have this as cosine theta I plus sine theta j, if we're writing it in a linear combination, such that theta is the angle from the positive x-axis to u. So that's this angle right here going from the positive x-axis always up to u. Okay, so theta is a direction angle of u. So now, for any vector v, v equals the magnitude of vector v times the cosine of theta sine theta, okay, times the vector. And so that's just another formula, just writing it out another way. Okay, so this says, so for any vector v, the unit vector v equals the magnitude of v times cosine of theta times sine of theta. So let's go on ahead and let's take a look, and these are just different ways of writing it. Okay, so this is the linear form. Okay, and there it is written out in the linear form, which is what we're going to be working with today. Okay, so tangent of theta is b over a. Okay, because tangent, right? So let's take a look. So tangent of theta is really y over x. And b here is our sine, or our y value, and a is our cosine, or our x value. Okay, so that's going to be tangent of theta equals b over a, or we can write it as tangent of theta equals sine theta over cosine theta, or we can also write it as tangent of theta equals the magnitude of v times the sine of theta divided by the magnitude of v times the cosine of theta. These magnitudes would cancel, and it would still just be sine of theta over cosine of theta. Okay? So these are just different ways of writing that. So now let's go on ahead and let's work a couple of problems related to this. Okay? So the first example says find the direction angle. It says find the direction angle of each vector. So the vector is u, and it's equals 3i plus 3j. Okay, so this is our a and this is our b. We could rewrite that vector like this. Okay? And now we're just going to find the direction angle. So the direction angle is tangent of theta equals b over a. Okay, so tangent of theta equals my b value, which is 3, over a. So now I'm going to have to swap these around and take the arctan, because I'm looking for an angle measure. So theta equals the arctangent, okay, which is that tan negative 1, and that's on your calculator, of 3 over 3, which is the same thing as 1. And that we can use our hand trick here, okay? And we know that tangent theta negative 1 equals 1, okay, when the number sine and cosine are the same. So that's going to be pi over 4, which is 45 degrees. So we know that theta equals 45 degrees, but tangent can be positive in 2 quadrants. It can be positive both in quadrant 1 and down here in quadrant 3. So it's going to be 45 or 225 degrees. Okay, and now we're going to go back up and we're going to look at these values to decide which quadrant it's in. So the a and b, the sine and cosine, are both positive, so it is not in quadrant 3, it's only quadrant 1. So our theta then is 45 degrees. Okay, so let's take a look at the next one. The next one is very similar. Right? So it says v equals 3i minus 4j. We can rewrite this as 3 comma negative 4. Okay, it's the vector 3, negative 4. Okay, so here, I'm just going to go on ahead and draw this one first. So we're going to go over 3 and down 4. So we know we're going to be in the 4th quadrant. Okay, so 4th quadrant, first thing. Okay, then we can go on ahead, and you could have done that first on this one too. I just chose to do it first on this one because I know it's going to be a little bit different. Okay, so this one right here, we're going to plug it in. So tangent of theta equals my b over my a. So now I'm going to do theta equals arctan of my b over my a. Oh, I forgot my arctan. Okay, so tan negative 1 of negative 4 over 3. And if I plug that into my calculator, I'm going to get negative 53.1. Okay, But remember that a direction angle, from this first page here, a direction angle is the angle from the positive x-axis to you. That means we don't need to find this angle right here on the bottom. We need to find the angle from this positive x-axis up and all the way around to there. Okay, so we're going to actually take 360 and subtract that 53.1, and that's going to give us a total of 306.9. Okay, and that's going to be our theta. Okay. All right, let's go on ahead and take a look at a couple of word problems here. See, I'm trying to shift stuff a little bit more so we can see better. All right, so the first one says, find the component form of the vector that represents the velocity of an airplane descending at a speed of 100 miles per hour at an angle 30 below the horizontal. Okay, so if we're going at 30 degrees below the horizontal at a speed of 100 miles per hour. Now, the first thing we're going to do, 30 degrees below the horizontal, we're going to start here and we're going to go until we're 30 degrees below the horizontal. Okay, so this is 180 plus 30 is going to give us our angle of 210 degrees. Okay, so that's our direction angle. And we know that this thing is 100 miles per hour. So that's right here, 100 miles per hour. And that's actually our magnitude. Okay. So we know that 100 equals absolute value of that vector. Okay, and 210 degrees is the angle. So now I'm going to plug it into this formula, and this is the one that we talked about on the first page here. Okay. So we're going to plug it into this formula here. Okay. And these are all the same formula, okay, but essentially it's going to be the magnitude of cosine of theta I plus the magnitude of the vector times sine theta I. This one right here is the one you're going to see used most often, just because then at the very end we can distribute that magnitude instead of distributing it as we go. Okay, so let's go on ahead and do that. So we're going to write the formula down, V, magnitude of V, times cosine of theta, sine theta. Okay. All right, so now let's go on ahead and do this. So we know that this is 100, and we know that our theta is 210. Okay. And then, so we're going to have cosine of theta, sine of theta. Okay. So now we need to find cosine of theta and sine of theta. So cosine of 210 and sine of 210. So cosine of 210 using a 30-degree reference angle, our cosine would be our x value. So that would be the negative square root of 3 over 2 for this third quadrant. Okay. And the sine of 210 using our unit circle would be negative 1/2. Okay. And now we're going to go on ahead and distribute this 100 through. Okay. So 100 times the negative square root of 3 divided by 2 is going to be negative 50 square roots of 3. Okay. I don't know why I wrote it so high up top. And then 100 times negative 1 divided by 2 is negative 50. Okay. So we can write it like that. Or, okay, it says write the component form. So we need to actually write it as negative 50 square roots of 3i. And then we could do plus negative 50j or minus 50j. Okay. So that is the component form of our vector right there. Okay. Then let's go ahead and let's do this last example today. So this one says, an airplane is traveling at a fixed altitude with a negligible wind velocity. The airplane is headed, all right, here comes picture time, north 30 degrees west. Okay, so this is a bearing of 30 degrees, okay, from the north at a speed of 500 miles per hour. So we know that our airplane speed is going to be 500. Okay? That's our magnitude. Okay? And then it says, as the airplane reaches a certain point, it encounters a wind with a velocity of 70 miles per hour in the direction of north 45 degrees east. So there's going to be this wind north 45 degrees east, okay, with a velocity of 70. Okay? So that is actually going to be added onto this, and we're going to have to find the resultant vector. Okay, so there we're going to actually go, okay, well, we have this 45 degree north 70 wind, and we have to find this resultant vector right there. Okay, so the first thing we need to do is we need to actually find the component form or vector form of these vectors. Okay, so magnitude is 500. Okay, cosine, all right, let's figure out what this angle is. Let's switch colors here for our airplane. We start at 0, we go up 90, and we go another 30. Okay, so that's actually going to be 120 degrees. And then we have our sine of 120 degrees. So now we're going to do 500 times. Let's see, the cosine of 120 is -1/2. I'm just using my unit circle. And the sine of 120 is square roots of 3/2. Now we're going to distribute this 500 to those, and we're going to get -250 and 250 square roots of 3. Okay? So that's my airplane. That's my airplane's vector. Okay, but now I need to find my wind's vector. Okay, so my wind's vector has a magnitude of 70. And our angle, well, if it was 45, if it was north 45 degrees east, and that's 45 degrees, then that means from my vertical up to that is also 45 degrees. So that's going to be cosine of 45, sine of 45. So 70 times, let's see, my cosine of 45 is √2/2, and my sine of 45 is √2/2. Okay, so that answer then is going to equal 35 square roots of 2 and 35 square roots of 2. So that's my wind. Okay, so now I need to combine these to find a unit vector. Okay, so our final then, when we combine these, so -250 plus 35 square roots of 2. All right, the final here in blue again. Okay, so the final is going to be -250 plus 35 square roots of 2. And then it's going to be 250 square roots of 3 plus 35 square roots of 2. Okay. Okay. So my final vector then is going to equal -200.5 and 482.5. So that's my final vector, but it says I need to find the resultant speed. So that was the speed, and I need to find the direction. Okay. So now I need to find the direction using tangent of theta. No, I lied. That's my vector. I need to find the speed. So my speed is going to be that formula that we've used in the past. So it's going to be the square root, right? So the square root of -200.5 plus 482.5 squared. And so my speed is going to be 522.5. Okay, so that's my speed. Okay, so this was my final vector, the actual spot where it's going. So it's going in the direction of -200.5 and up to 482.5, wherever that point may be. Okay, but my speed, my actual magnitude, right? So speed. So I plug it into this absolute value, essentially formula, distance formula. It's 522.5. Now I need to find the direction, and that's going to be that tangent of theta equals that 482.5 over -200.5. Okay, and when I do that, I get a direction of 112.6 degrees. Okay, So it's going somewhere right up in this direction, okay, which sounds right based on the actual vector that we have here. So if we take this vector and we draw it, so negative 100, negative 200, we'll make these about the same length. So we're going to go up 4, almost 5 for this one. Okay, so around right there. Okay. So, I mean, this is 90 degrees, so this is pretty close. It looks like it could be 112.6 degrees. Okay, so we know we're on the right track because it actually, looks like that vector. And then the speed of that thing is at 522.5. Okay. So I know this is a lot of work, okay, but really, anytime you're finding a resultant speed and direction, you're going to have to combine these, okay, add them together. Okay? This one right here, it was just one single vector that we had to actually find the speed. That we were given the speed and the direction angle, and we had to actually find the vector. Okay, so make sure that you know the difference between those two. There are going to be some problems like this. So make sure that you understand how to do those. I'll see you guys next time.